All right. Okay, we're going to start with domains of inverses. Okay? Domains of inverses. Whenever we find an inverse, what do we do? What's that first step we do when we find an inverse? Switching x and y's. So, domains of inverses, domains and ranges of inverses, we can actually find without even finding the inverse. Because the range of a function is the domain of its inverse, and the domain of a function is the range of its inverse, right? Because to find the inverse, we'll switch x and y, so it makes sense that the domain and range are going to switch there, right? So you're going to see some problems whenever we get to test time for this Wednesday, where it's going to say find the domain of the inverse of f of x equals. So one thing you got to be careful is make sure you're reading the question really carefully, because there will be questions that just ask you for the domain, like we saw on the quiz that we had yesterday. But then there will also be questions that ask you for the domain of the inverse. So make sure you're reading them carefully, because students will make that mistake. So whenever we're doing domain of inverse, we could switch x and y's, find the domain, find the inverse. But even that will be somewhat misleading there. So what we can do here is we can just think about domain and range of f of x. So for f of x, okay, this is not going to be our answer because this is f of x. We need to think about our domain and our range. All right. So for this domain, this is just a quadratic, right? It's a quadratic. It has been moved to the right 3 and up 5. So it's going to look something like this, right? As far as domain x values, what is our domain for that function? Negative infinity to positive infinity. Okay? What is our range? I heard 3 and I heard 5. Which one is it going to be? Okay? It's going to be 5 because this has been moved up 5. The 3 is how far it's been moved left to right, which doesn't affect your range. So it's going to be from 5 to infinity. I've messed up. What did I do wrong? I need a bracket. We're going to include that 5 because it actually hits that bottom point. Okay? So without even knowing what the inverse is, for f inverse of x, domain is 5 to infinity, and range would be negative infinity to positive infinity. And so this question was particularly asking for domain of the inverse, so this part would be our answer. Okay, questions here? All right, here's our next one. We've got 4 over x minus 4 plus 9. So just like we did on the last one, let's think about what f of x is like. Right, so for domain and range. And as you can see here, we're doing these without a graph, so you'll be expected to be able to tell these without graphing them. So domain, think of what's happening here. We've got the 4 in the top. What is that going to do to the graph? Vertical expansion. That is not going to affect your domain and range. Right? Expansions and compressions do not affect domain and range. So we basically ignore it for this. If you were asked to find a graph, you would need to pay attention to it. Or if you were asked for transformations, you would need to pay attention to it. But for domain and range, you're basically just ignoring that 4 in the top. The 3 right here is going to move us right 3. 9 is going to be up 9. So that vertical asymptote is going to move over here to 3. That horizontal asymptote will move up here to 9. So this is 3. No, right there is 9. And it will look like this. Oops. All right, so for our domain, for this, we're thinking about what x values we cannot have. What x values can we not have? 3. So we would have negative infinity to 3 and 3 to infinity. Range would be negative infinity to 9 and 9 to infinity. So everything except for 9 there. So that means that those switch for the inverse. So it would be negative infinity to 9 and 9 to infinity here, and then negative infinity to 3 and 3 to infinity here. This particular question only asked us about domain of the inverse, so this is our answer. And I'm going through this so that you can find domain or range. You could just do one of them here because it's only asking for that, but it doesn't hurt us to think about all of the possibilities here. Okay, questions so far? All right. Domain of the inverse for this one. So if we're just thinking about f of x for domain, what would we have? And so what is underneath the square root? What do we know about it? Greater than or equal to 0. It can equal 0 because the square root of 0 is 0. So x has to be greater than or equal to 4. So if we do interval notation, that is, bracket 4 to infinity. Say that again.
We only have to know domain, but how would we use range?
So,
Just think about your graph. Ask John.
yeah. So, but you are correct. We're going to think about the graph for that. Yes. It does reflect over the x. Is that going to change? That, so this is moved like to the right 4, and it's flipped upside down. Does that reflection over the x, does it change the domain? It does not. So with square roots, you can always just take what's under the square root, set it greater than or equal to 0. If there is a negative inside of here that flips it over the y-axis, that it'll be taken care of whenever you're solving that inequality. So as long as you remember to, when you divide by a negative, to flip that inequality sign. So you can always, for square roots, just take the inside of the square root, set it greater than or equal to 0. But that negative right there is going to affect our range. Okay? Because normally, this would be up here. When we flip it, it changes our range because what is the very lowest number we're going to have this now? Negative infinity up to 0. Whereas without that negative, it would be 0 to positive infinity. But the question didn't ask us about domain and range of f of x. It asked us about f inverse of x. So range would be, I'm sorry, I don't know why I wrote range first. Domain would be negative infinity to 0, and range would be 4 to infinity. All right, so our answer to this question here would be negative infinity to 0. I do want us to look at this one because all right, here's something really cool about Desmos, and one of the reasons I don't give it to you on a lot of this stuff right now. All right, here is our equation. What is our first step for finding the inverse? Switch x and y. Look what you can do on Desmos. You can find the inverse just by switching x and y. You don't even have to solve it. So like if there was one where you needed to find the inverse and I gave you Desmos, which I'm not going to do a lot, you could just do this and then check all your answer choices and see which one gives you that blue graph right there. Which is why Desmos is so cool. Not in this unit. A lot of times, like, I can't say for sure because this is way too far in the future for me to say for sure. A lot of times when it comes like midterm time, I might just give you Desmos on the whole thing, even though it is kind of cheating on it. But since it's cumulative, I might do that. But that's too far in the future for me to know for sure what I will do. But now I just want to show you this really quickly. It didn't ask us to do this, but if I solve this, if I solve this, I switch to x and y's. I've got x equals negative square root of y minus 4. If I divide by that negative, I'll get negative x equals the square root of y minus 4. I would square both sides. Negative x squared would equal y minus 4. And then I have negative x squared plus 4 equals y. So my graph, if I graph that, y equals negative x squared plus 4. What did I do now? Did I do something right there? Switch your x and y's. I did that, right? X equals negative y minus 4. I got rid of that negative on the outside. Oh, I know what I did wrong. I got rid of the negative first. That means I'm squaring negative x, right? Because, let me go back. Let me go back so I can explain that adequately. Because Desmos is right. I'm wrong. Here, I got to get rid of that negative 1. So negative x equals the square root of y minus 4. So when I square both sides, I'm squaring this whole thing, not just the x. And I didn't do that correctly. So when I square a negative x squared, it's just going to be x squared equals y minus 4. And so I'll get x squared plus 4 equals y. There will not be a negative there. So let's get rid of this negative. So if I look at this graph versus that blue graph right there, it's not the whole graph, right? So whenever you're doing inverses of these, you technically need to restrict your domain on your answer. So while my answer would be y equals x squared plus 4, it would only be for whenever, for this domain, for negative infinity up to 0. Right? I'd only use that left-hand side of the graph because the quadratic itself would include parts of the square root that don't really exist from the original function. So I don't think you'll see anything where you're asked to figure that out, but if you ever see answer choices where you have, like, this is your function and your inverses, like, have this restriction out to the end where x is less than or equal to 0 or something like that, that's what they have done on those problems there. All right, so try these two on your own. Well, do I mean that?
Can you do the
First one, super duper easy, but you don't realize it's super duper easy. What type of fun? We probably just need this together. Okay, all right. It's not irrational.
Not irrational.
It's not irrational. Where does the x have to be for it to be rational? On the bottom. What is this?
It's unrational.
linear?
It's irrational.
It's not irrational. It's linear.
I was
This is just linear. Because when I see x plus 7 over 5, I could do the love connection here,
55x plus.
right? I could divide both of those numbers by 5 because I just have a single number on the bottom. So this is really, that's a 1 in front of that, so it'd be 1/5 x plus 7/5. So this is just a line with a y-intercept at 7/5, a slope of 1/5. Okay, linear. What's the domain of a linear function? All real numbers. What's range of a linear function? All real numbers. So when you switch those, you get the same thing for the inverse. So your domain here, and your range, but it didn't ask us for it, would just be negative infinity to negative infinity to positive infinity. That's a sneaky one right there because really it's a super easy problem, and if I had given it to you as f of x equals 1/5 x plus 7/5, you probably would have done better with it. But it's a sneaky linear that's trying to pretend that it's actually rational, but it is not. It's just linear. Yeah, so 5 is like just a complicated function, right? It's rational, but it's also got a square root in it. So we don't really have a picture in our minds of what this is going to look like. I'm going to graph it on Desmos just so you guys can see. But this will be without Desmos, so I'll show you how to do it without also. Was it +2? So it looks like this. It's kind of like half of a rational, but it's a little bit less symmetrical looking here. It doesn't have this portion over here of the graph. Now, looking at this graph, can you tell me the domain by looking at that graph? Negative, what'd you say? -2 to positive infinity. I think it looks like we got a vertical asymptote right there. So, from the graph, you might be able to come up with it, but this is going to be without a graph. Okay? So let's think about what gives us issues with a domain. What can we not have when we look at a function? We cannot have, underneath the square root, we cannot have negatives, right? So normally we take x plus 2 and we set it greater than or equal to 0. But for this problem, can x plus 2 equal 0? It cannot because it's in the denominator. And if I have a 0 in the denominator, I'm getting 1 over 0, and what is that? Undefined. So for this particular case, because that square root is in the denominator, it's just going to be greater than 0. And so we will subtract the 2. X will be greater than -2. And so domain, you might see it written as x is greater than -2, or if we do that with intervals, it'll look like this.
Is range be negative infinity to positive? Is there like a
I probably won't ask you for range for this because we don't have like a picture of what that looks like in our head. So I probably won't ask you for that. Oh, wait. Hold on. I don't know that I really meant to ask you for the...
Well, no, we have to find range to find.
Yeah, we got to find range because we're asked for the... I don't think I'm really going to ask you this. I think I meant for this question to be different. Let me think here.
Is there a horizontal aspect?
Yeah, there is. There's going to be a horizontal asymptote because could you ever have a negative number on that bottom? It's got to be positive because square root of something's going to have to be positive.
Zero.
So 0 is your 0 to infinity is your range.
Will you ask us range?
You have to find range to find inverse.
I need to rethink this right here. Domain then would be 0 to infinity. Range would be -2 to infinity. And so this is asking for domain. I will look through the test. We won't have a quiz on this section. It'll just be on test. I will look through the test and see. Without a graph, I may ask you for domain of f of x or range of the inverse. I do not think I would ask you for range of f of x or domain without a graph here. I think I'd put a graph with it if I was going to give you that. I'll look through the test and make sure that's true, though. Because this is when most of the range we usually think about picturing it. Okay, questions? All right, composites. Okay, so a composite function, when you see that phrase, composite function, that means something like f of g of x. You're putting a function inside of a function, right? So the domain of f of g of x is the intersection of the domain of g of x and f of g of x. Okay? Intersection, that word intersection means the overlap. Okay? So we're thinking about, we have to have values that are both in the domain of g and the domain of f of g of x. So it's where those two things overlap for us. So if we're looking at A, where it asks us for the domain of f of g of x. So whenever we're finding f of g of x, like if I were finding f of g of 4, right, of a number, I would plug the number into the g of x first. That's my inside function. So if I get undefined there, then I can't get a value for f of g of x, right? So we have to check the inside function first, right? So for my inside function, so for my domain of g of x, I've got a quadratic here, x plus 1 squared. What's the domain of a quadratic? All real numbers. Negative infinity to positive infinity, right? So there are no restrictions on this domain that come from that g of x for this problem. Okay? So after I check the inside part for restrictions, then I need to look at f of g of x. So if I do f of g of x, that will be the square root of x plus 1 squared minus 4. No. The square root and the square do not cancel because you've got this minus 4 over here. If you just had square root of x plus 1 squared like that, then square root and square would cancel. But because of this minus 4 over here on the end, that is not going to be the case. If you think about this with numbers, like if I had the square root of 3 squared minus 4, right, if we do this like we normally would do, that'd be square root of 9 minus 4, which is square root of 5, right? If you did this where that 3 in the, like if you took the square root of both, if you did square root of 3, square root is 3, square root of 4 is 2, you get 1. That would be wrong, right? So if you have plus or minus signs, you cannot simplify that or square root each one separately if you got that plus or minus. So we cannot really do anything here to simplify this. We can, but it's not going to really get us anywhere on this one. So let's think about the issues though, because when we think about domains, problems with domains, let's list them out. So when we think about domains, we cannot have zeros in a denominator. We cannot have negatives under a square root. We cannot do a log of 0 or a negative number. I'm trying to think if there's any other issue. You won't see trig right now. Trig can give you some issues, but you won't see trig right now. I think that's everything we should run into. We might have to come back and add to this list if I've missed something. So, when we find f of g of x, we need to be thinking I cannot have zeros in the denominator of a fraction. Do I have any fractions here? So is that going to be an issue? No. I cannot have negatives under the square root. That is going to be an issue for us here, right? And I cannot do logs of 0 or a negative number. Logs are not an issue on this problem, right? So my problem here is that what is underneath this square root, x plus 1 squared minus 4, has to be greater than or equal to 0, right? Because I cannot have a negative. So if I make this greater than or equal to 0, that shows me what I will get that is positive here. So to solve this, I could add 4 to both sides. I'd get x plus 1 squared is greater than or equal to 4. Alright, here is where our warm-up comes in. I'm going to move this down and give myself a little more room. Sorry to you guys, because you can't do that. Now, what do we need to do to get rid of that square? We need to square root. Square root's the inverse of a square, right? Now, here's the problem. If that was an equal sign, I'm going to write this over to the side just so you can see. X plus 1 squared equals 4. We would square root both sides. We would get x plus 1 equals 2. And what would we put with that 2? Plus or minus. That works great when we have an equal sign. It does not work when we have an inequality sign. Because saying that something is greater than or equal to plus or minus 2 doesn't really make sense, right? Because why wouldn't you just use the -2? So it's not going to work that way when you have an inequality sign. So the other way we could have done this right here is we could have written this over here. We don't usually, but we could write it this way. Absolute value of x plus 1 equals 2. Because that means when we have absolute value, that means x plus 1 can equal 2, or x plus 1 can equal -2. So when we're doing this with an inequality, it will look like this. When you're square rooting both sides and there's an inequality there, you need to put absolute value of x plus 1 is greater than or equal to 2. Don't put the plus or minus. It'll be taken care of in the next step, right? So let's make ourselves a note right there of what we're doing. With inequalities, and everybody understands when I'm saying inequalities, I mean there's a greater than, less than, greater than or equal to, less than or equal to sign. If you square root both sides, put absolute value bars around the it's not always on the left, it's usually on the left, the variable expression, I guess. Variable expression. So here's where that warm-up comes in. This is x plus 1 is greater than or equal to 2, or, because it's greater, which sounds a little bit like it has the word or in it, if you exaggerate it a little bit, less than or equal to -2, like we were doing on the warm-up. So here, x is greater than or equal to 1 when you subtract that 1, or x is less than or equal to -3 whenever you subtract that 1. So we need to consider the domain of G. Domain of G had no restriction, so it's not really going to affect anything, right? And the domain of f of g of x. So this is our domain right here. It written as, if you think about what this looks like, you got numbers greater than or equal to 1 and less than or equal to -3. So if you wrote that in interval notation, it would be -infinity to -3 and 1 to infinity. Now, if there was some restriction on the domain from G, we'd need to include that as well. Like if x couldn't equal 7, we'd need to throw out 7. 7 couldn't be there. But this had no restriction, so it really didn't affect our domain over here.
So if we had that restriction, then we could only write x is less than or would we do
So like if, let's say there was like an x cannot equal 7, you would do -infinity to -3. You do 1 to 7 with the parentheses, and then 7 to infinity. So it would be everything in this domain except for you'd have to take 7 out of it, if there were that restriction there. But there is not, so this would be our answer. Okay? Now, g of f of x is not going to be the same. There are times when it can be the same, but for this particular problem, it will not be. All right, so we need to consider domain of the inside first for g of f of x. So domain of f of x. F of x is the square root of x minus 4. For the square root of x minus 4, we know x minus 4 has to be greater than or equal to 0. So x would be greater than or equal to 4. So that is part of our domain. Even if we get like all real numbers for g of f of x, the domain has to be at the very least x is greater than or equal to 4. All right, because if you get undefined when you plug the number into f, then you're also getting undefined when you do g of f of x, because you've got nothing to plug into g if you get nothing out of your f. So this is going to be part of our domain. What we need to do is find g of f of x to see if anything is added to that. Okay, so if we're doing g of f of x here, we would have square root of x minus 4 plus 1 squared. All right, question is, does that square get rid of that square root? Some of you might be like, I really think it does, but the way she asked that question makes me think the answer is probably no, right? So if that square gets rid of the square root, then you'd have no restrictions on this. But you don't necessarily have to do this, but let me show you why it does not. Oops. Get rid of. So when we have that squared, it means you write that twice. Then you would have to distribute. What is the square root of x minus 4 times the square root of x minus 4? It is just x minus 4, because it's like the square root of something twice, which means the square root of that squared. Square root squares cancel each other out. You just get x minus 4. Right here, though, we would have plus 1 times the square root of x minus 4. In our inner terms, we would get another plus 1 square root of x minus 4. And then for our last terms, we would get a plus 1. So you would end up with x, that negative 4 right here, and that 1 right here can be put together, so x minus 3. But these two square root of x minus 4s, you would just have to combine them. It'd be plus 2 square root of x minus 4. All right, so the square root of x minus 4 would still be there, even if you expanded this out. It does not get rid of your square. So in this case, you don't necessarily have to do that work to show that you did that, but you need to know that will not get rid of the square root. So our issue is still that you have this value underneath that square root, right? So that's our issue with this problem. It would still be x minus 4 needs to be greater than or equal to 0, which would just give us x minus 4 is greater than or equal to 4 again, right? So the domain of this is also the same as the domain of f of x for this one. So our domain of g of f of x would be 4 to infinity.
So why would you include like the plus 1 square root?
Those numbers are not going to give us anything that would be undefined. Okay, so whenever we're thinking about our function that we're dealing with, the stuff we're looking for are these things up here. Zeros in the denominator of a fraction. We don't have any zeros and we don't have any fractions, so that's not going to happen. Negatives under the square root, so that's right here. That's what we considered. And logs of 0 negative numbers, which we don't have. So that plus 1 is not going to make it undefined. It's only the stuff underneath the square root that is going to make it undefined. Now, up here was more complicated because everything ended up under the square root. So it changed it. But here, the only stuff under the square root is just that x minus 4. So it's just whatever's under that square root is what you're dealing with. Okay? All right, questions? Yeah. You're welcome. Domains of inverses. If students know how to do domain and range, students usually do pretty well with domains of inverses, except for sometimes they don't read the question carefully enough to realize it was asking for the inverse. Composite functions are tougher. This is one of the tougher things in this unit, too, I think. They're a little confusing. Yeah. But what we're doing is we're looking at domain of inside, so the inside function, and then we have to look at g of f of x, or f of g of x. So let's do some more so we get some more practice with this. All right, here's our next one. So, and for all of these, I'm asking you f of g of x and g of f of x so that we see that they could be the same, but they're not always the same. So, if I have 2x minus 4 and I've got 4 over x plus 3. If I'm looking at f of g of x, we care about the inside function first, right? So, domain of g of x. That's what we're thinking of first. Because if we get an undefined for that, we'll have an undefined for the whole thing. Problems that I'm thinking of, I'm looking for that square root. I'm looking for fractions. I'm looking for logs. Those are the things that give me problems. For g of x, what do we have? We got a fraction. And with a fraction, what cannot equal 0? Denominator. So our denominator, x plus 3, cannot equal 0. Okay? Even though that's a not equal sign, you can solve it like it's an equation. So x does not equal negative 3. So for g of x, we could have everything except for the number 3. Any number is okay except for, not 3, negative 3. If I were writing that in interval notation, it would be negative infinity to negative 3 and negative 3 to infinity. Everything except for negative 3. So no matter what we get for f of g of x, we know we cannot have negative 3. That has to be a restriction on our domain. Okay? So I'm going to do now f of g of x. So f of g of x is going to be 2 times 4 over x plus 3 minus 4, like this. And if I try to simplify some here, this 2 is like a 2 over 1, so if I multiply it there, I'm getting 8 over x plus 3 minus 4. Yes, because a coefficient, to multiply fractions, we just multiply straight across. But to do that, we have to have a denominator there. And so if we have a whole number, we can just put it over 1. All right, so whenever I have this, I can't really simplify it any further. I'm looking for square roots, zeros in the bottom of a fraction, logs. I don't have square roots or logs, right? The only thing that I care about is the bottom of this fraction right here. And I know that it cannot equal 0, so it cannot equal negative 3. That's the same thing we got for our domain of G, right? So since they are the same, we just have that same domain. So our domain for this one would just be that same thing we had over here. Okay? So a lot of times, like, one of these f of g of x will only have like one restriction because whatever g of x is turns out to be the same for f of g of x. But let's think about whether g of f of x is going to be the same. Okay? So we always look at the inside first. Domain of f of x. What is our domain of f of x? All real numbers. We don't have any square roots, we don't have any fractions, we don't have any logs, it's just all real numbers. So then we have to think about g of f of x. So that is going to be 4 over, and then here we'll have 2x minus 4 plus 3. Which, if I simplify here, is 2x minus 1. So, this time, I'm thinking square roots, zeros in the denominator fraction, logs. Which one of those do I have? Fraction. So I know whatever is in the bottom of this fraction right here cannot equal 0. So, 2x minus 1 cannot equal 0. So if I move the 1 over, 2x cannot equal 1, divide by my 2, x cannot equal 1/2. So for this problem, my domain of f was all real numbers, so it doesn't really affect anything. There were no issues there. G of f of x will either, I can write it as x does not equal 1/2 sometimes, but if it's interval notation, which you're more likely to see, that would be negative infinity to 1/2 and 1/2 to infinity.
So is that like 1/2? Let's say a vertical asymptote or something.
Yeah, on this one it would look like a vertical asymptote, yeah. All right, what questions do you guys have on this? Okay? This is one of those things that I have to reteach to myself every year to make sure I'm getting it right. So, ask questions if you have them. This year I did almost was like, I got it. But I still went and reworked a couple problems because it's a little confusing. Okay. Domain for f of g of x here. I'm going to look at g of x. The inside first. For g of x. What would my domain be? I'm just going to write x cannot equal negative 2 here, or negative infinity to negative 2 and negative 2 to infinity, but it's easy to write x cannot equal negative 2. Alright, so when I do f of g of x, I will have 3 over 1 over x plus 2. And dividing fractions is easy as pie. Flip the second and multiply, which will give me 3 times x plus 2 over 1, which is just 3x plus 6 there. Hello? That's okay. Yes, that will be fine. I've got third planning, so that'll work just fine. Okay, thanks. Bye. All right, so we got 3x plus 6. Are there any restrictions on that?
No.
We don't have square roots, we don't have fractions, we don't have logs. Those are the 3 things that we're looking for that are going to give us restrictions. So the domain of this would be all real numbers, but we got to think about what g of x was, right? And it had a restriction that x could not equal negative 2. And if we put negative 2 in here for g of x, we'd get undefined, which means we got to get undefined for the whole thing. So even though we get all real numbers here, because g of x, x could not equal 2, our answer for domain of f of g of x would be x cannot equal negative 2, or we could write it negative infinity to negative 2 and negative 2 to infinity. Okay?
So then why did you even have to do the other part?
You mean that second part?
Yeah.
Sometimes there can be like a discontinuity that shows up over here whenever you're doing this part. So it can, like, if we got something, like, for example, say that this had an x on the top of it, which it doesn't, then we would have an x in the bottom right here, and x could not equal 0. So then we would say x could not equal negative 2 or 0. You would exclude both of those points. Does that make sense? So sometimes something shows up over here, but not always. Let's see if it happens on f of x. I can't remember if it does. I don't think it does. All right, so g of f of x, we look at f of x first. F of x, what is our problem with f of x? What can x not equal? 0. All right, g of f of x, okay? I think it's going to happen here, actually. I would have 1 over 3 over x plus 2. Oh, yeah, it's going to happen here. Can I do dividing fractions easy as pie, flip the second, multiply on this one? I cannot, because I do have a fraction here, 3 over x, but the whole thing is not a fraction. So we have a denominator of a fraction here. What can that not equal? 0. So we're going to say 3 over x plus 2 cannot equal 0. And we just solve this like an equation. So I would subtract 2. So 3 over x cannot equal negative 2. Oh, what do I do here? Multiply by x, because x is in the bottom. We can't solve for x while it's in the bottom. We need to get it out. So 3 cannot equal negative 2x. So divide by negative 2. So x cannot equal negative 3/2. So this one is an example of what you were asking earlier. So the reason we got to check that second one is because we ended up with a second restriction on this, right? So for f of g of x for our domain, it would need to be x cannot equal 0 and x cannot equal negative 3/2. Oops, sorry. Wrote it backwards. And if we wrote it with interval notation, this would be negative infinity to negative 3/2. Negative 3/2 up to 0. 0 to infinity. So there's an example of where you have 2 restrictions on your domain, so you got to include both of them. Yes?
Okay, so,
That is not true. Right. Yeah. Yeah. It's for denominators, it's just not equal to 0. You can have negatives in the denominator, you just can't have 0 in the denominator. For square roots, no negatives in the square root. Alright. Okay, everybody, you may pack up, but do so quietly while I'm showing you guys what you have for your assignment for this one. Alright, we've done Desmo's classroom in here with you guys before, right? So you guys are in the class. So you'll go to the class, and there is an assignment here called Domains of Inverses and Composites. And here's what it's going to look like. You will have, these are card matching sets, okay? So, there will be a card that says functions, f of x equals g of x equals. This is not a card to match. It's the one that gives you your functions. Do not try to match it with anything. It should be alone, okay? So then, you will have all of these different things, right? I've got all of these things it's asking me about. I'm going to move these over here. These are all domains, right? I've got all of these functions. So if, like, I look at f of x, what is my domain for just f of x? It is greater than or equal to 3. Because whatever's under that square root has to be greater than or equal to 0. So that would be greater than or equal to 3. So I would match that here. Then I would think of g of x. I'd think about the domain for it. What's the domain for 3x plus 5? All real numbers, right? Yes. Then I've got my inverses. So I would think about my inverses. This is like the first part. Think about the range of f of x and g of x to get those domains of the inverses, right? You're going to switch those. And then you'll do what we were just doing with composite functions to decide what f of g of x and g of f of x are. So sometimes these will be, like for example, linear functions. You have all real numbers for both, right? So the inverse of g of x is also going to be all real numbers. Your domain for that will also be all real numbers. So sometimes you'll have more than one function that goes with a domain. But you should have one that matches to each domain there, at least one. There, so you'll match all of these. I'm just going to randomly select here what the answers are. Probably not getting these right here. And then when you go to the next slide, it tells you how many you've got right. And so you would need to go back and try to get those right. Please try to actually do these, like write them out, think about them. I realize you could just like guess and check until you get it to be correct. And if it comes down to that to like help you figure out the answer, that's okay. But try to think about what these are as you do them. Yes. I think if you get the 10 out of 11 right, that it tells you they're all correct. Because on the answer key, I'm pretty sure. I think it should tell you that all are correct. If you don't see that and you're getting 10 out of 11, I think you're okay. Well, because I think it would be at least in pairs of 2 that it's going to count them wrong.